Okay, so I'm set up here to place some very small parts on this circuit board. And I really wanted to do this just to demonstrate two things. One is how I get it done, and two is to talk about the difference between hand skills and technique. I think of it as hand technique. I have dysgraphia, and it seems to have affected my small motor skills. Doing things inside my hands movement are really imprecise. And so in order to do things with small components, one of which you can barely see inside this plastic container right here, I have to use the best technique I can because my skills are not so good. So first I'm going to pick up one of these LEDs here, and in my normal ADHD and dysgraphic way, I seem to have made a mess out of some of these LEDs here, which I try not to do. But I don't want to have to step over other LEDs, so I'm starting right here. And you notice this hand here, this left hand, I'm using it to support my right hand and to control it. And you notice I got a little bit of shakes there. I'm not sure why I have the shakes, but they're not very big. They're about a 32nd of an inch. So I'm going to just take a deep breath, and as I'm exhaling, I'm going to lower it down. And the exhale bit seems to be really important. I learned that doing photography, and I wanted also to get this little component here. It is a capacitor, and it is really teeny. Yeah, won't focus on it, but you get a sense. It's smaller than a piece of rice. It's bigger than a sesame seed, though. Take a big deep breath and exhale again as I set it down. There's solder paste on here. I have to be careful not to make a big mess out of it, but not crazy careful. And so I lower this with my left hand. And it is good technique that allows me, hand technique, that allows me to do things like this and work on small devices like iPods and phones. It's important to have good tools. They can be cheap, but they've got to be just the right tools. I like these ones with a bend in them because they make my job just a little bit easier. I have a whole collection of tweezers of different kinds and a bunch of different pliers. And they're pretty cheap to get. If the tips don't come right together, then they're no good. Sometimes you can sharpen them so that they do. So that is the end of my video. But almost always, if you're trying to do something fine, using both hands and having your place of support close to the ends of your fingers, like I will rest my hand on something sometimes. In this case, I use the fingers on my left hand to raise and lower my right hand. It works really well for me. Thanks. I hope it helps. So if you're watching me, you'll see that I'm using both hands and that I really lower this with my left. I have my right arm resting across the front of the desk on my forearm. This one I made more difficult than it needed to be. I taped these down in the wrong place and I'm messing them up a little bit too much. I like taping down the strip in a place that's convenient, and this time I wanted it in the video. I would have made it a little bit further away with a nice pivot so I could just get in there, but it's too close and it gets munged up. The markings of pin 1 on these LEDs is not easy to see. There's a little bit taken off a corner. However, you can look inside and they have a dark spot. I guess that's across from pin 5. And so they're easy to check. One of the things that I did do is I only uncovered about half of these so that I could only mess up half at a time. And I wanted to talk a little bit about solder paste. I'm using leaded solder paste because this is only my maybe fourth circuit board of surface mount devices. But and I thought that leaded would be much easier on my hot plate because the temperatures are lower, which makes you have more time to deal with it. But if you're lax about washing your hands after regular solder, boy, with this solder paste, you really shouldn't be. I think that because of the oxide coating on old solder, it's a mistake to be lax with solder at all, and that you should be really good about washing your hands. And I think that you should do that even with lead-free solder. The electronics industry is rife with poisonous things. So now I've turned the board around. I've got to turn the LEDs around. I really would like these things to be square and neat. And most of the circuit boards that you've seen me use, I have these LEDs robotically put on. But I wanted to be able to repair. And I also thought that this might substantively open up things for me to do because of the smaller costs, the smaller development time, and the ability to warehouse my own parts. And I also thought that repair of the boards I am using would be nice, being able to repair them. Another part of this is that if my assembly house doesn't stock the parts, I generally have to order them in full reels to make it smart. And it can be a lot of money. So I wanted to know how to stick them down. A lot of things are only available in surface mount parts. So I decided I better get at it. I'm far enough along here. I'm going to turn my hot plate on. It's set to 210 degrees Celsius. And it really is pretty slow. So I'm going to go around and check and make sure each and every one is in the right position, the right orientation, and make sure they're neat enough, not just to work. I don't really want this thing looking too sloppy. And one of the reasons I'm so careful in setting things down is that pushing them around is not that easy, and I have not had that much luck with having the surface tension of the solder straighten them up. Okay, well, that's it. As soon as my hot plate heats up, I'm going to move it over to the hot plate. The hot plate is over here. Okay, well, here's my soldering hot plate. Not quite a temperature yet. Okay, well, here we are. Here's my cheapo Chinese hot plate. It is currently heating up to 210 degrees. It's at 209, and I guess because of the algorithm, it takes a long time to get between 209 and 210. And that's Celsius. So I'm going to slide my circuit board on there, and in doing this I look around and see which parts are floating off of the hot surface, because they will definitely solder down slower, and I've found that I have to push them down. You can see there's some smoke coming off. Some of it is steam. Starting to look around for places that are melting. This part is high. I'm going to push it down for a little bit. Just get it started. Over here. Over here. These are melting over here. Some of the ones on the other side there's a bunch of them melting. I don't know if you can see them shine in the camera or not, but you can see them going from wet gray to shiny. This is the wrong tool to be using. Maybe if I use this end right now it'll work. Ew, I goofed one up. It'll work. These over here haven't melted. You can see I'm going. Okay, all of those have gone. There's some over here that haven't melted, so I'm holding those down. I'm going to just get a different tool. Throw this one away. I thought it was a better plastic than it is. And if you can't see a melt, you can definitely see the solder bead up. Okay, all of these look like they have gone sufficiently. I'm going to pull an edge off of this so I can pick it up with a pair of pliers. Going to carefully pick it up with my nice parallel jaw pliers. And then carefully move it over to a place where it can cool. I find that process, just moving it, very difficult. So there it is. I can turn off my hot plate and stop recording.